Hello and welcome to the class of GSM. So today in our class we are going to discuss about GSM bands. So if we talk about band is basically a range of frequency. So we have for GSM band we have 1900, 900, 1800 megahertz and 1900 megahertz bands available for GSM services. So this is for radio communication we require frequency. Frequency. So we have a relationship between the frequency and distance. That frequency is inversely proportional to distance. So if you have lesser frequency, the greater the distance it will cover. And if you have more frequency, the distance covered will be less. That means they are in inverse relationship to one another. So if we talk about as per the standards, we have recommended that for GSM we have these three bands available. Now we have lesser frequency, that means it will cover up the more distance. So this band will be preferred most. And then this and after that this. But each and every band has some specific capacity and specific range of frequencies. Now let's discuss about very first band, which is 900 megahertz. Now from network, like this is a network and this is a user. When it communicates to with the network, the user communicate with the network, so we call it as this link is uplink. And when network communicates with this, we require this link is downlink. Uplink and downlink. So we require a frequency for uplink and we require frequency for downlink too. All the uplink signals will pass through this frequency and downlink signals from F2 frequency. So we have divided band like this. So we talk about 900 megahertz band. As per its division, it is 890 to 915 megahertz and 935 to 960 megahertz. Now this frequency we have reserved for uplink and this frequency for down. So while lesser the frequency for uplink, because UE or mobile station has a lesser power and it requires to cover up the distance to the network. So lesser frequency, it will cover more distance. More frequency, less distance, but the power of the network is more as compared to mobile station. Now the space, that means this space. We call this space as channel spacing. Channel spacing. I can say that if in a FDD mode we have divided. FDD, frequency division duplex. This is a frequency, this is a time. So we have this as uplink. We have this thing as downlink. In between we have this channel spacing. Now why channel spacing is required? So that uplink frequencies will not interfere with our downlink frequencies. That's why we need to give here channel spacing. Now if we calculate the total channel spacing of this band, CS is equal to 935 minus 915. 935 minus 915, which comes as 20 megahertz. So we have provided 20 megahertz as a channel spacing in this band. Now let's calculate about total capacity of this band. So to 890, then we have 915. That means how many? We have 25 frequencies in this. So 890, then we have 891. In between, we have FDM, frequency division duplex. That means 890.1, 890.2, so on up to. Now, here in this case, we require to space. That means 20 kilohertz we require to have spacing between the carrier or 0.2 megahertz. So if we give 890, then we have to leave 1 and after that 890.2, because we need to have a gap of 200 kilohertz or 0.2 megahertz. This will be possible from this. So that means we have 10 divisions, but we have neglected one because we need to provide a space, because again interference problem. So that means we are left with only 5. So we can multiply this number 25 with 5. So we have 125. So again, I will clear this. From 890 to 890, we have 10 divisions further FDMA. But we need to provide a space between the carriers so that carriers will not interfere with one another. Because in FDMA, we have to take care of interference at the most. So we have 10, but after spacing, we need to leave 5. Then we are left with only 5. So 25 multiplied by 5, we have total number 125. But we have to leave 1 as a guard. So we are left with 124 number. That means in 900 megahertz band, we have total 124 ARFCN. Now this ARFCN as absolute radio frequency channel number. So this is basically the number of the total channel. For example, we have ARFCN1 corresponding to this, we have frequency 890. Number 2, 890.2, because we are leaving 0.2 megahertz as spacing between the carriers. Then 890.4. Now this is a frequency and this is a channel number. So this we call it as absolute radio frequency channel number. So this is how we calculate the total number of ARFCN in a band. Now, other than this, we have concept of duplex spacing. Duplex spacing is basically the space between the first downlink and first uplink. It will be same because we require a dual carrier for uplink and downlink also. From last to last, again the same difference will be there. So here in this case, we have 935 minus 890, which comes as 45 megahertz. So 45 megahertz duplex spacing is there in this 900 megahertz band. Now, as we see that we have only 124 ARFCN in this band. That means if we have companies which purchase 40, 40, 40, so around 3 companies can work in this band. Other has to jump to another band. So when we go to purchase the spectrum, it is on the basis of first come first serve basis, or we have a bidding method. Whatever the country is using, so it has to operator has to purchase these ARFCN number, and then on these ARFCN number it can work. This is about GSM 900 megahertz band. Thank you so much.